Hello. Hello. Good morning.
Good morning.
How are you?
I'm fine, thank you. How are you?
Any question?
I have just one simple question about the week 6 assignment.
Week 6 assignment. Okay, one moment. Okay. Let me share the screen. Week 6 assignment. Okay, which one?
Can you just scroll down a little bit?
Mm-hmm.
The p2.dim function. What does it actually show? That dim, the dimension.
P2.dim.
Yes.
DIM is a dimension. You show the dimension.
But does it show like the highest degree of the x or?
No. It actually. Okay, let me show you. Okay, let me show you how to use this one. Okay, it's a polynomial. Okay, here you have. We want you to create a polynomial class. Okay, and it want you to show the degree of the polynomials. Okay, so what it actually want you to see is that you have a polynomial. Polynomial is supposed to be axn plus bxn minus 1 plus cxn minus 2 plus blah 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 plus the last one maybe z. Okay, I'm sorry, maybe a0, right? A0 is x to the degree 0, right?
Mm-hmm.
So basically the highest degree is your dimension. So here is dimension n.
Yeah.
Okay, so here you have the so-called this one's so-called coefficient list, right? So say the coefficient lists are representing, say, 1 to 1. This really means like this x squared, x and 1, right? So actually it's x squared plus 2x plus 1, right? So the dimension of this polynomial is 2.
Okay.
So basically here you have 3 elements. I think that the dimension you should just return what? You have 3 elements, the dimension is 2. So what should you return?
You return 2, right?
You return 2, and how you get 2?
That's the problem because I use the length.
It's the length of the list minus 1.
Yeah.
Is okay? Yeah.
But if you have only x to the 4th, it doesn't work.
You only have what?
X to the 4th. Only x to the 4th.
X to the 4th still work. Why not?
It's gonna show 0.
No. It won't. You have the x to the power 4. Your coefficient should be 0, 0, 0, 0, 1.
Okay.
So you need to fill in these in your coefficient list.
Oh, okay. Yeah, I think it should work then.
Is that okay?
Yeah.
Okay. Any more question?
No, not about this.
This is the case, right? This actually is the case.
Yeah.
Okay.
Yeah, I should have tried it before.
That's the case. That's the case. Okay. Any more question? Yeah, no problem. Any more question?
I do. Hi, Professor. I have a question on creating the log plots.
Creating the log plot. Okay, let me actually show you. Okay, don't forget about the sorting part portions. Okay, the portion. I just create one log plot for you. Is that okay? I just try to create one log plot for you.
Yes, thank you.
So let's assume that here, let's see, we are in this one, okay? So right now we are week 4, so let's go to week 4. So window R, I'm sorry, right here, I hit window R. We're not a command line, okay, a moment. Let me cd to this directory. Okay, and type code. Okay, put in my Visual Studio Code. Okay, one moment, okay? Let me get some function. Okay, so here we have start and stop. There's a linear space. There is something called log space, right? So we teach you sometime before with the so-called linear space. Okay. So here, let's see. One moment, okay. The Visual Studio Code is coming up. Okay, right here. Let's try this one, okay? Let's try this. So here, let's actually try this one. Let's call it plot log, okay? Plot log. So plotting the log chart, okay? Okay, sorry for it. Actually, every time we bring out a Visual Studio Code, it takes a while. Maybe my computer is old. Maybe I had too much junk. Okay, it's okay. So now we are here. So we do from PyLab. Okay, import start. Okay, you can use import numpy, import matplotlib, pyplot. Okay, that's actually you can do that. But anyway, we are in here, right? So normally we have. So I'll also import. Okay, numpy as np. Okay. So normally we will do this one, x equals numpy the linear space, okay, from 0 to 100, okay, 101 point, okay, something like that. And we plot y equals av, actually say t square, okay, I'm sorry, 2t, okay, so that's use a 2 times t, okay, for t in X. Okay, so these are linear space. Okay, these are linear space. So linear space, we have this one show. Okay, here we do plot. Okay, plot what? Plot X and Y, and then blue color. Okay, so this one's normal linear plot. Okay, so this one, let me actually run it. So linear plot means from 0 to 100, there are 101 point. So every number 1, 2, 3, 4, I give it a point. Okay, I give you a point. And here I'm plotting 2x. Okay, 2x. For every x, I double it. Okay, so the plot is 2x. Sorry, first time we run Python and the PyLab actually take a while. Okay, sorry for that. I may have to buy a newer computer. Okay, slow. Okay, let me actually do this. Okay, while we are waiting, let me copy. Okay, this one, let me actually put it as plot linear. Okay, so this one's plot linear. Let me actually pass the whole program to here, and it really is plot linear. Okay, it's not plotting log chart. So this one's plot linear. So this one plot linear. That actually put it here. Okay, so this is plot linear. We finish. Okay, we finished. I back up to plot linear. So now let's actually go here. Let's change it to log space. Okay, log space. So log space, I would like to start from 10, right? 10 actually is 10 is what? Is 10 1 to the power 2 1, right? So we will do 10 up to 1E5, okay, and totally 5 points. Is okay? That's log space. So you can create a log space. So at this moment, your X scale is log space. Y scale actually, your X scale right now actually is by the order of 10. Okay, by the order of 10, but it's still linear space. When you plot it, it's still linear space. Okay, it's linear space. So that it is safe. And that's wrong it. Okay. So you see it actually is what? 1e to the power 10, right? So here actually the plot, we don't see the data. Okay, we don't see the data. The power base overflow encountered in power. Okay. So let's check the log space. Okay. Let's check the lower space. Number equal 50. Okay, base equals 10. So here let's see, number equals 50. Okay, so here let's actually do totally number of 5 points, base equals 10. Okay, let's use this. Okay. Try one more time. Okay, try one more time. We still don't get the plot. One moment. Okay. So here, let's see here. Is start to stop num and endpoint. Okay, let's see. Log space. Okay, log space is 10 to the power 2. Okay, this one, sorry, actually using log. Okay, so log is 3.0 to 3.0. Okay, and to number 4. Okay, so this one base 2. Okay, so let me change it. Okay, change it. So it is in log scale. So here, let me use 1 to 5, base 10, 5 point. Okay, let's try this one. Let me close this one. Okay. This one is to create your X data in log scale. Okay, we got it, right? We got it. So you see it actually is 10 to the power 1. Okay, 10 to the power 2 up to 10 to the power 5. It actually create 5 points, and then those 5 points are in the log scale. Okay, in the log scale. So let's try here. Okay, before we plot, we do this one. We do print my X. Okay, my X sequence equals X. Okay, print my Y sequence equals Y. Okay, so print this X and Y. Okay, and Y is double of X, so it should be okay. So you see this one, you have the X in this way, right? So it actually is the 10 to the power 1. So this log scale means that your X is what? Using the base. Okay, so you assign the base 10. So base 10 of 1, 2, 3, 4, up to 5 is okay. You can create a log scale number with that. Is okay? And your
Yes.
Y is double, but at this moment, your chart still linear chart. Okay, this plot is linear chart. So let's actually look at different way of plotting it. Okay, different way of plotting it. So we have plot is actually linear chart. Okay, so when you do plot, it actually is linear chart. Okay, linear space chart. So we have numpy, and we can use numpy. Okay, and let's use a log. Okay, linear plot. Okay, there's a log and linear plot. Okay, second one is apply the log scale. Okay, let's see. Log space. Okay, let me see. There's a log plot. Okay, let's try log plot. Okay, let's try log plot. So here, if we don't use a plot, I comment it out. Okay, the same plot I can use log xy. Okay, and then use let's try this. Okay, use blue, same blue color. Okay, so this one will create a log chart. Okay, Let me see. At this moment, your unit is linear. Okay, let's close this linear chart. So let me change it to green. Okay, so we know that log chart is in green. Save. Let's run it. Okay, so here is you see the scale. The scale is log scale. And right here, this side, Y also being take log. Is that okay? Let's call log chart.
Okay.
So that's actually, this one is log chart compared with the first one that actually is linear chart. But there is still another one called log linear plot. Okay, so X log scale and Y linear scale. Okay, so there's another way you can do X log scale chart. Plot, okay, X log scale and the Y linear scale. There's another option of doing this, okay. Log means axis, okay. You can try to see it here, okay. So you have plot, okay, your normal plot, okay. This one is X linear, Y log chart, okay. So here you can do, let's see, it actually set axis to log, Y scale to log, okay. So let's try this one, okay. Let's try this one. So this one is not hard, okay. This one actually, you have the figure, okay. You can create figure, okay, and you will get the axis, okay. So let's do this one, okay. This one we log chart, okay. Let me comment on log chart, okay. And here I create a figure and I assign to the figure, okay. And the figure I can get the axis, and axis is the figure. Okay, let's don't call it figure, call it figure, okay. So figure that get current axis, okay, get current axis. So and then we do put axis by scale, okay. And then after that we do what? We do plot X, Y, and B. Okay, let's see this one, okay. So this one, let's see, here we have this one, we do plot. Let's see. Okay, so it actually should use, okay, let's try this one. Okay, let's actually try axis. Okay, let's try the axis. Okay, this is the part that is. Oh, I'm sorry. Here I have a HRA. Okay, so this one is a linear log scale. Is that okay? So let me try this way. Okay, let me try this way. This is actually a little bit complicated now. So let me copy it for 3 parts. Okay, copy for 3 parts. So after class, you can still use it. Okay, let me copy for 3 parts. So first part, let me actually delete all of these. Okay, so here I'm going to use plot. Okay, first figure, I'm going to do that. Then second part, I call it figure 1. Okay, so figure 1, I do figure and get figure 1, and this portion, I don't do this one. Okay, so here I delete this one and delete these things. Okay, we do figure 1. So here we have a, here we create a figure plus the normal plot. Second, we plot the log plot. Okay, third one we do figure 2, and figure 2 set up for, so this one is actually I write it. Okay, so first one is linear plot. Okay, second one is log plot. Okay, third one is linear and log. Okay, first one is X and Y. Okay, second one Y, but X and Y. Okay, so we save this. Let me actually close this chart. Okay, so first one I use blue, second one green, third one let me use red. Okay, so let's save. Run one more time. Okay, one more time, we get the linear chart is blue, then you close, you come up with the green, log chart green, and close, you come up with this one, linear log plot. Is that okay?
Yes, thank you.
Okay, so right here, I show you how to create a log space and get its Y function, okay, based on it, and then also plot it in linear chart, log plot, and the linear log plot, okay? Okay, one moment, okay, let me take the question from here, okay? Okay, whatever, good, okay. Hello. Hi, Jonathan, how are you? Any more question?
Yeah, hi. Can you hear me, Professor?
Yes, I hear you, yes.
I was just curious. I have the results for my, the execution time for the project, and mine seemed to be a little bit higher than what your example graph was for the selection sort. And I just was wondering if
that could be because the CPU can be different.
Okay.
And the environment could be different. You may run multiple processes at the same time. So we don't know what's going on. Maybe your memory too small and then you always swap in, swap out. That's also possible.
Okay. I just
so unless it's totally dead, otherwise we should compare your machine with your machine. Your different algorithm on the same machine. That's okay. It's just a example of how to measure time. You know what I'm saying?
Mm-hmm. I was just concerned by how much off my results were compared to yours, because yours ended up basically at like 10 to the 2.
Yeah.
And my I don't want to
unless your algorithm is wrong. If your algorithm is correct, shouldn't be a problem. And then to speed up, you just buy a supercomputer. That's it, right?
Yeah. So I mean, I understand that Python is going to be considerably slower than like compiled languages for something like this.
If you are using Python, I'm using Python, so it should be language-wise should not be a problem.
Okay,
Have you tried different IDEs? Because that's what I've been doing. I've been using 2 different IDEs just to test the speeds against each other.
Typically, if you run like using this wrong, I believe it would be slower than you use a terminal. Because you submit to the OS directory, yes.
Okay, because I'm using mine in actually in Visual Studio, not VS Code.
Yeah, Visual Studio is.
And I'm not launching it from a terminal, like you said.
Way too much overhead. Way too much overhead.
Okay.
Yeah, I notice a difference when I use the two different IDEs that I'm using. There is a difference of the speed, and so that is unique too. And I was just like, oh wow! But I keep doing it anyway, and I take like 5 or 6 different samples of each one from both IDEs, and it's different. So I was just like, okay.
Yeah, I think my algorithms are right. I've done most of these sorts, multiple times in multiple classes now, and I'm there is a chance, of course, that I have something wrong with it.
That's assume that there's no problem there, but machine do make difference, language do make difference. Yes.
Okay, because my bubble sort took like way too long.
Yeah, it did with the 100,000.
Yep.
Yeah, it took mine's like, I think I clocked it at like 25 or 26 minutes or something like that.
Yeah.
So it took a long time versus doing it in like insertion sort. The insertion sort was like 5 or 6 minutes.
So, I try to calculate how many individual words, okay, that Bible has, right? So let's assume that you actually has different words, okay? So say there's a Bible all somewhat around this many words, okay? Around this many words, about 800K words, okay? Almost 1 million words in the whole Bible book. And I try to find out individual letters such as say a word, okay, that actually is one word, okay, and a wood, okay, that's a separate word, right? So totally I count the number of words in the whole Bible, and it takes roughly maybe what actually 3 hours something to finish it. So depend on your computation, okay, depend on your computation. You do not expect every program to finish in 1 second, maybe not, okay? Depend on your computation. And also depend on which language you use. Okay, so say your Python, your Python, you run bubble sort, you end up with, let's say, this 100,000 sample one, right? You may end up with, say, let's assume that you spend half an hour. Okay, so roughly that's, say, 1,000 second. Is that okay? Say 1,000 second. Let me see. It's 1,000. Okay, so that's assume that actually 2,000 second. Okay, 2,000 second. Okay, 60 second a minute. Okay, so that's assume that it's a 2,000 second, and it's roughly around 30 minutes, right? But the same problem in Java, I would say maybe drop down to at least it would drop down to somewhere around maybe 1,000 or less. Okay, and going to C++, I think this whole number could drop down to maybe 100 seconds, maybe.
Oh,
It's an
wow.
order of 10. If you are using C language or assembly, I would say it may be 10 seconds.
Okay, as long as it's kind of like what I was asking along those lines, and I didn't want to go into my numbers in case other people still had to work through theirs, but
as long as your data is consistent on the same machine, same installation, same OS, same language.
okay.
That's the environment I want you to have. So there's no need that you compare C++ to C or to anything. It's just a practice of how you measure your algorithm in a certain installation. But if you do feel that in the future, okay, in the future you do feel like, okay, this Python really slow, so let's try speed up using C++. Is that okay? That's the purpose you study programming language. You install some program in certain language on certain machine, and you figure out, hey, that's too slow. Then you need to speed up. Speed up means that you may change machine or even change language. You know what I'm saying?
Yeah, and I think this
Yeah.
project is like a great great example of this because of how long
Yes,
mine took
yes. The whole
compared to.
purpose is just want you to experience that. Okay, some program do take longer time, and at a certain situation, you may want to use a C++ to speed up. Okay, so Python. So this number one, this is something called C Python. You know, there's one program called C Python. Okay, so what's the difference between C Python and Python? Do you know?
No.
Okay, C Python is still Python. Okay, still Python. So you still write everything in Python language. Okay, but the bottom line virtual machine is all in C language.
But I thought that was the same thing with Python anyway.
The language wise is the same.
Okay.
Just the virtual machine is being written in different way.
Oh,
it's
okay.
defined as the interpreter and compiler, whatever what you see here, right?
Mm-hmm.
So later half of this course, we do introduce C Python and interpretation of C Python.
Okay.
So basically here we use Python as a pilot language, but later we do want to dive into the issue of when your program is too slow, okay, then C Python is a reference implementation of Python. So in a way, the programming language you are writing still be in Python language, but we do use a C as the interpreter and compiler to speed up the Python.
Okay, because I was looking into, I've done a bunch of Java as well. I was looking into, I know in some of the other like Eclipse IDE, I was able to set the settings of the JVM so I could like increase memory or things like
Yes,
that.
yes,
I was
yes.
wondering if maybe that was part of what was bottlenecking it. So I was talking to some friends and stuff as well that
At
work
this
on software,
moment,
and
probably not. Probably because your machine is too slow or something.
I actually have
And
like
you
I think it's
do,
just Visual Studio
yeah,
because my computer is
yeah. Okay.
it's not.
Talking about Visual Studio, it can be like this, okay? It can be that you have a Visual Studio, right? So you have a Visual Studio. You have a lightweight Visual Studio C, right? So the difference is that you already load up the whole .NET framework into here. So it take up a whole big space of memory there. And when you do actually compilation and then programming in there, your process maybe swap in and swap out. OS, right? OS actually do scheduling. You need to swap in, swap out sometimes. But this one, the core is tiny. So most of the memory space, you are just doing interpretation for you. So less swap in, swap out. So unless that you really need to use the .NET framework, otherwise Visual Studio have no advantage.
Okay. Yeah, in the future, if I have to do anything like this, I'll probably try to stick to terminal or a lower overhead
Yes,
IDE.
yes.
Okay.
That's why we introduced either this one, what's that? Actually, the idle or the Visual Studio Code. Okay, we can introduce Eclipse or Visual Studio Code that a lot of people use, but that bring in a lot of overhead. Okay, that bring in a lot of overhead. Unless that you kind of has some sort of supercomputer. Okay, especially in some company, the setup is better. So everybody has the top of the line machine and set up. So they may like to use Eclipse or like to use some commercial IDE and then have the group type of environment set up, unless that there are certain people maintaining that every day. Otherwise, Visual Studio Code always be lighter and better. You know what I'm saying?
Yeah.
And if you feel like normal Python is too slow, try install this C Python. It will be faster.
Okay.
Okay. It actually will compile Python into bytecode. Okay, into bytecode. And bytecode actually, you can also enjoy the just-in-time compilation using that. And in fact, the bytecode sometimes you can also run Python in Java virtual machine actually. Python can also be run. Python can be run on Java virtual machine. In fact, it is. Okay. So Python, Java virtual machine interpreter, they do have something like this. You know what I'm saying? There are 200 more language being run in Java virtual machine right now, including Scala, Kotlin, many language you know. Scala, you know Scala? Scala language. They are also running on Java virtual machine. Okay, Scala. Okay, so virtual machine is just an interpreter. It actually fully running on Java virtual machine. Okay. But that's the speed up portion. First, usually we do problem solving. We have using Python to solve the prototyping. Okay. Any more question?
No, I was just saying I'll just, like you suggested, I'll keep my environment the same for this whole project, just so the data doesn't get different. But in the future, I might swap to VS Code or something else if I have a big project like this. Thank you.
Yeah, no problem. No problem. You're welcome. Okay, so that's that. This week. Wait. Okay, so this week 4 we are on the imperative programming, right? And week 5 we are on object-oriented programming. Okay, so if you have any question about this week and the next week object-oriented program, you are also welcome to ask. Okay. Okay, one thing is like object-oriented programming in Python is actually lighter weight, okay, because Python by itself actually has no concept of the type, okay. It doesn't declare integer or whatever. So object-oriented programming, if you want to learn the object-oriented programming knowledge, Java still be a better language to learn. Okay, Java still a better language to learn, but Python do have some feature, but not really that complete. So we do use it. We use Python as the pilot language just because that it has good support in functional programming, much better than Java. Okay, and functional programming is the key that in AI people would use. Okay, so that's because of that. Otherwise, language-wise, virtual machine Java is the best. Okay, virtual machine Java is the best. Okay, and recently we do see some trend to go to the so-called C low-level virtual machine. Okay, so C low-level is client C. Okay, client C low-level machine. That means that, okay, how about this? Let me actually translate everything into low-level virtual machine. Okay, this one would be faster than Java virtual machine. It's actually C assembly like. Okay, so whoever high-level language just compile to this, and this one have an interface with the different, say, A15 processor, maybe also the Intel Fatist x86 family. Okay, so even ARM, strong ARM, super strong ARM processor. So it provides some kind of hiding on the hardware. So now recently there is a trend to compile everything to a low-level virtual machine. Okay, so make the core be platform independent. So your Word, okay, Microsoft Word can be migrated from ARM system to Apple system to Intel system really quickly. Okay, there's such a trend to have that. Okay, it's actually C language family from for low-level virtual machine. Is okay. There are something like that going on right now. Low-level virtual machine project. Many people try to support it right now. It's okay, but we do not have the time to go this low level. But they do have such a project going on right now. Okay, any more question?
Yeah, I had one about the I think it's the final project, the term project. Was that we have to write an interpreter? One of the options was to write an interpreter for scheme language.
Yes, actually, these are candidates. You can write interpreter for anything.
Oh, okay.
The whole course, our goal is to interpretation of some sort. Is okay?
Yeah.
Okay, the whole course's main idea is to interpretation. That means you have a language one coming out with language two. Okay.
Jonathan, did you have any ideas that you thought of maybe that you would do yourself besides the recommended projects there?
Well, sorry, I had someone come up to me that I had to write something down for, but what I wanted to say, the first link there is not a valid link anymore. The one to the cs61a.org, I think, and I might be wrong.
That one is only an option. Yeah, you can check that one, and you can browse through the internet. There are many projects in that direction. Okay, but it's okay. You do this. Okay, let me give you an idea. Okay, so let's assume that you actually have a language. Okay, you do a circle. Okay, 10, 100. Let's assume that. Okay, and you actually translate to some sort of maybe Pygame or anything. You do draw a circle, center as 10, and then radius 100. That's also translation. So then you next one, you have a rectangle, okay, 100, 100 something. You translate to this. And the next one, you can have what? You can have a polynomial, polygon, okay, sorry, polygon. Polygon, and the polygon should be have point, a point list, and going back to the first point. So it actually should be something like this. Is that okay?
Yeah, I follow. To answer your question, Shauna, I don't have any idea just yet. I see that the proposal's due on week 10, and so it's coming up. We're on week 4 right now. But I was looking ahead to it, and I don't know what I'm going to do. So I was trying to go off of those links and get some ideas. Interpreting a language is, I guess, probably would be the most helpful one. I know. I talked to some of my other teachers, and they were talking about writing a compiler, which is a lot more complicated, right?
Yeah. Compiler is acceptable, but not recommended. Yeah.
An interpreter would be a little easier than that, but
so this way you are translating English to figure, right? So if we are doing the opposite way, okay, we are doing the opposite way. We are doing the opposite way. You have a circle, you have a triangle, you have a square, and then you translate to another one, say circle, and then 10, 10, 100. From here to here, this one, we call it vision, right? Computer vision. So from this circle to graph, this one we call it synthesis, right? Graphic synthesis. You create a graphic. Is that okay? Yeah.
Now, Jonathan, when you say your other teachers, because are you in a class where you actually walk into class and have a live setting or anything?
No.
Okay.
No, but I talked with some of my teachers like in depth from last semester. And
okay.
He was talking about like his master's. He's writing I think it's a compiler for his master's.
Okay.
And that's
but,
that's a little beyond what I could do right now. I know that.
But compiler is one. If you are a CS major student, it's a once in a lifetime event you must do. You know what I'm saying? Compiler is hard, but actually it's a once of a lifetime. If you are CS student, I always suggest student to do at least design one compiler by himself. If you are CS major, it is considered to be C1, C2, C3, C4, C5. This is a C ++5 language. I do recommend some student after programming language to take compiler design course, and in his lifetime to design one compiler by himself. Okay. So basically, you did heard some professor did a compiler design in their master project, right? Okay, that's good.
Yeah.
So to me, okay, I graduated from CS, computer science and engineering. Let's look at what's big things in CS. Okay, if you can do the following, one of the 3 things in the following, I would say you are expert in CS. Okay, number 1 is a standalone compiler designed by yourself. Okay, no problem. Second one, if you can handcraft a CPU. Third one, you can handwrite a brand new OS. If you can do one of these in your lifetime, you should be able to start any company at any time. Believe me, you should have the power to do that. If you can do any one of these, you will have the power to become a startup company key engineer. Okay. And for me, I go through computer science. In my master degree, our PhD qualified exam, screening exam, we do this in 1 hour.
Whoa.
You go to the room with a professor, and he give you some paper and a big whiteboard. you start to write something within 1 hour, that it should be a working CPU with data path and control unit and instruction set. So same thing, okay?
That's impressive.
Yeah,
so
yeah, right.
that's something you can do. If you have the power, you should be able to do anything. One of these, okay? One of these. So
That's
you
pretty
are,
cool.
if you are
Yeah.
able to write an Android OS by yourself, right? You can start a company at any time.
That's
You know
pretty
what I'm saying?
hard because like a lot of the operating systems are built off of other ones, or at least
Yes,
they're
yes,
yeah.
Linux, yeah,
So
Linux. So if you own the power to design any one of these, you are able to start a company. For sure. Okay, for sure. But very few people can do that. Okay, I have to say very few people. That's why here you see that I list down the course difficulty, right? At the top level is actually represent these three things. You know what I'm saying? If you can do a compiler, you can do a microprocessor, you can do a OS, you should be able to go anywhere to start a company without any other people's help. You know what I'm saying? That's the goal. That's the goal of top engineer. Okay.
mhm.
But usually the processor and OS nowadays is too big for even trying. Okay. Because a microprocessor, meaningful microprocessor right now probably need 200 Intel engineers. So that already out of the reality to be able to be crafted. You can design some small, tiny processor, okay, 8-bit, 4-bit one maybe. But nowadays to design a 64-bit 3 cache and then multi-core processor, that's almost impossible. Okay. So more doable one is actually this one, to design some compiler. And compiler can be used for any language translation. As I said, shape figure to language, that actually is computer vision. From language to the shape, that's called synthesis. Okay, same thing for speech to word to speech. They have what? Speech recognition, and also the other way is speech synthesis. You know what I'm saying? Those are also compiler of some sort. You know, okay?
Hmm.
And why this one, we actually call it what? Structure and interpretation of computer programs. So usually you go to interview, you are in there to interview for problem solving skills. So they give you a graph problem, okay, dynamic programming problem, and then you study the code, and then you go through there and you pass it, right? You try to pass it, right? That's the total
Right.
pass. But this interpreter is actually bigger than that. Okay? Usually, if you know how to do this, you should be able to handle a whole project. Okay? We are trying to give you the kind of, not the capability, but at least have the vision that to look into the bigger project. Is okay?
Yes.
Yeah, that's a goal. Okay,
Yes.
that's a goal. That's a goal. Okay, we can teach this course in several different ways, right? Some professor teach programming language in a way that, okay, let's study 20 languages. Okay, every single one, you just what? You just have a little sip, right? Just like you drink cola and then one sip and go away. Try to do another one, right? That you are not going to learn anything. We try to focus on one thing that's called language interpretation. Is that okay?
Hmm.
Yeah, that's a key. We try to help you to understand how languages are interpreted and how we apply this technology to different domains. So we pick this textbook, even though this textbook is written in Scheme at MIT, but I
Right. That's MIT, right?
yeah, that's MIT, yes. And I try to translate it into Python domain for you. Is that okay?
Yeah, no, I actually really like your slides and everything.
Yeah.
I like the class, and I love on your videos when you pull up the pen and you draw your hand drawn diagrams. Some of that is like extremely helpful, so far, at least in the lectures.
I try, yeah, I try my best. The idea is that, okay, why people has this course, okay, and MIT has this course very long ago, okay. This one is not like 10-year course. I think in early 80s, MIT already has this course, okay. And very interesting is that, okay, MIT give up this course, okay. At this moment, MIT no longer teach this course. The last time they offer this course is in the year 2019, okay? And somehow Berkeley, about 15, 10, 20, maybe 15, 20 years ago, they start to teach the 61A, to teach the same course in Python at the freshman level. You know what I'm saying? At the freshman level. So the kind of the
Hurts.
yeah, that course average is like 50, 60. I mean, that's how this one you see, this one CS61A Berkeley, okay.
We're seniors and they're
This is where this course is, okay. And they teach very broad, but for me, I actually rewrite it. I actually focus the whole thing on language interpretation. They even teach SQL or something. Okay, they teach a lot of things. But this one is a reference site. It's always open for everybody. You know what I'm saying?
Oh, good.
It's always open for everybody. You can even browse through this one. You can do Berkeley. Okay, CS61A. Okay, it's an open course. So you can find a lot of video there, but I guarantee you they teach in a way that it's harder for you to understand.
Gotcha.
Okay, but it's a very important course. They look at this one as their fundamental course to teach people for AI. And what good about Berkeley is that Berkeley has a new division of computer, data science, and society. Okay, what this one is that they group their top program, like, okay, they have a top program in X, right? Electrical engineering and computer science, stats department, data science, computational biology. They group everything into a new program called this one called computing, data science, and society. They are going to promote this one to a new college. You know what I'm saying? So they are going to actually trying to promote this one to becoming a new college of data, computing, and the society. They are promoting something like that. Okay, and they are building the building for it that can accommodate 3,000 people. Okay, so this is the way that data science is moving. Okay, including computer science, traditional computer science, school of information, and statistics for machine learning, something like that. Okay, and also data science. They group.
How close do you live to there? From there, I mean,
25 miles. I can take our subway to there.
Oh, cool. Okay.
Yeah, my home to UC Berkeley. Okay, let me show you my home to UC Berkeley. UC Berkeley. Let me use a map. Okay. This UC Berkeley, and then I use what direction? Right. Let me see direction. Okay, direction, and from my home. Okay, my location. Okay, and it's a straight line. You see, it's a straight line, and I can take what? Let me take the no. I actually can take transit. You know, it's a straight line. It actually just take one bar. My home is like 5 minutes away from my subway to there, another station at UC Berkeley. That's it. One transit. That's it.
Gotcha.
Straight line. Okay. Very close. Yeah, and Stanford is not far away. Stanford is over here.
Oh, really?
Stanford is over here. even closer to my home. Stanford is just here. I used to go to HP near Stanford to work.
Oh, really?
Yeah. I was a HP employee before in HP lab. Okay. The whole point is we are moving this way, right? At this moment, we are moving into the AI way, right? And AI in a way is translation. Okay. So in the old day, okay, in the past few years, I'm using the other textbook, this one called Programming Language Pragmatic. This one is a good book, but they teach in the traditional way. You know what I'm saying? Traditional way means that, okay, let's talk about how compiler is designed, and then let's talk about different language, 20 different languages. Okay, he teach in that way. This one is a good textbook, but in a way, I feel okay. This kind of teaching does not support AI too much. You know what I'm saying? And a lot of students come to this programming language course just because what? Because they have this course listed as required course in their undergraduate CS curriculum, right? Otherwise, a lot of students may not even take this programming language course, right? So for me, I figure out, hey, this is not the right way to waste time. Let's do it in this different way. Let's learn how to use a programming language translation skill as a stepping stone for learning AI. Is that okay?
Yeah.
Yeah, that's the way I'm teaching. So that's why, you know, when you have a question about making plots, okay, trying to do data visualization, I strongly support it. You know what I'm saying? Eventually, we are doing data science in a way, okay? Very few people had a chance to design a compiler, to be honest, right? Unless that you work for Microsoft to develop a Visual Studio Code, right? Or you work for Apple to design the Xcode box, okay? The Xcode.
Oracle.
Yeah, very few company really hire people to do compiler design. Yeah, Oracle doing future Java version, right? So very few people really do that. But most of the people would be go into the machine learning and also what? Data science. And in fact, machine learning right now is very hard, okay?
That's what I was thinking about getting my master's in.
Okay, so actually a lot of people trying to, 275K? Okay, don't be surprised, that's the real number, okay? That's the real number. That's really a real number, okay? This one is a real number. Hey, don't be surprised, these are true, okay? Let's look at some. I have a son who is actually only freshman in Berkeley, okay? He tried to apply for this one, summer internship, okay, summer internship. So at this moment, say this is a big end, he got into this one, okay? This is what, full time it can be over 200, okay? 20,000, yeah. Wow. 200, okay. Only for the summer, he's actually hourly pay over 50.
Wait, excuse me. I'm sorry. So I think I saw an intern like this with Google, and I wasn't sure if that number was right. So you said hits, because that internship had like 65,000, and it was more geared into like entry level machine learning, data science. So you're saying that would have been 50,000. That is $50,000 for just the internship?
No, the internship is $50 per hour.
$50 per hour. Okay.
Yeah, but if you translate it into monthly pay, okay, let's assume that each week you work on, each day you work on 8 hours, right? So that's a $400 a day, right? So you may have 30 days, you may have 31 days, and then your real working day may be 22 days or 23 days, right? Let's pick 23. So you have 400 times 23. How much it is? Already over 9,000. right? 23 times 400 already this much a month, right? Times 12. That's already 110K. And this is an intern, okay? This is intern. It's not real full-time employee.
I know. Oh gosh.
Okay, this is only intern, and he is only freshman. So let's take
Wow.
away the word intern. Okay. So let's actually put this one, and this company is okay pay, not the top pay. Okay, this one still okay pay, not the top pay. Hey, this one is annual salary is actually what, this much, right? Not including bonus. Including bonus, that would close to this much.
That sounds so good. Bonuses.
Not including bonus.
Yes.
Not including bonus.
Equity bonus.
Yeah.
Yeah, I like those numbers
Okay.
also.
Okay.
Right. I'm like all over here happy, right? It just shows
Yeah,
we have to work a little, we have to work really hard, but we can get there.
No, I think that the CT make a difference. The way you are hired also make a difference.
Mhm.
I think if you are hired by it at Illinois, it could be lower.
Yeah.
If you hire at Chicago, it could be lower than San Francisco. You see
New
here?
York, San Francisco.
This is not kidding, right? This number is not kidding. You know what I'm saying?
That's nice.
These are real numbers. Some people post it on internet. These are some numbers, okay? Well, but living costs also higher anyway. You have to, I mean, overall you can. So you can try to check the number, okay? This is called levels.fyi, okay? Levels.fyi, okay? This one. Okay, they do have different kind of number of different level.
I was checking that in December
Yeah,
for like Chicago area.
yeah. You can try to find that, okay?
Mhm.
But typically I would say top student, okay, top student, and actually say UC Berkeley, okay, UC Berkeley, or maybe Stanford, okay, Stanford. Starting salary, I would say this much is normal. You want to say this is normal, and plus bonus of this much is actually typical. Okay, sign-in bonus of this is typical. But if you want to break, say you want to break your 200K, you have to be really good. Okay, you have to be really, but not really hurt. Okay, recently a lot of people get 250 something. Okay, not really really hurt, but typical packages like this right now. Yeah, that's a typical package if you graduate from this different school. But if you are graduating from, say, UC Davis, okay, the middle UC, that we say, okay, the middle UC that we say, then typically you get maybe 75K to 90K, okay, that's a typical range, plus maybe 20K sign-in bonus.
And that's for what?
That's for middle UC. UC had 9 campuses, you know what I'm saying?
Okay.
And if you are UC Berkeley, UCLA, that's the top range.
What about us, Lewis University?
I don't know. Okay. The good thing about the interview right now is that if you can pass the code, they will pay you the same way. You know what I'm saying?
Okay, the leak, yeah, because I'm on leak code doing problems.
Yeah, but well, they are fair. I think they are fair. Okay, I don't think they are unfair. Just looking at your university, I don't think so. Okay, but usually, say Berkeley students have higher chance to win the job because they
make
are
money. Yeah.
Yeah, they are better in terms of taking those legal tests. Okay.
Mm-hmm.
Yeah.
They're higher.
But
any of those schools, they're gonna get out making great money.
Yeah, but if you are as good as them in coding, then I think you will be paid in the same way.
Oh no.
Yeah, but you have to try really hard. You know what I'm saying?
Right.
You
I
have to
know
try
it's gonna
really
take
hard.
some time. And I think it's gonna, I'm probably have to take the first year in industry and then go to I don't know, we're gonna figure it out, but I'm gonna make my 6 figures and plus 2, and it's not gonna take too long.
Yeah, the thing is like to be hired by a decent company, I would say at least a 300 plus legal problems.
Mm-hmm.
Okay, and maybe 2/3 should be medium plus.
Gotcha.
1/3 easy, maybe okay, but maybe a few hard one, okay. And majority of the medium problem you should be able to solve.
And they actually are like on YouTube, there's people that explain some of those problems too. So like if you just can't answer it, they give you the answer in leak code, but they also got people on YouTube that's explaining it.
Yeah, the way to train you is like this, okay.
Mm-hmm.
First, you go into the problem solving, right?
Okay.
And you do struggle, right?
Yes, you do struggle.
So if you are able to solve it in 2 days or 3 days, okay, that's good, okay. And you should try different ways. So the first time you may be using array. Second time you use a hash map, okay, whatever. You try different way to solve the same problem. Just try to get more exercise, okay. But if after 3 days you're still there, okay, and getting no solution, you should look at the solution at that time.
Okay.
And then try to understand it. And then what? Erase whatever you have written down. Redo it many, many times until you do not rely on any of the solution.
Gotcha.
Then it become your own knowledge. You know what I'm saying?
Mm-hmm.
Yeah. But if you don't struggle and then you directly go into solution, sorry, that is not going to help you. That's other people's knowledge. You know what I'm saying?
Mm-hmm.
You can cheat yourself, but you cannot cheat the people, right?
Right. You can't cheat the process.
You cannot cheat the process. Yes.
Yeah.
Yeah. Okay, but that's the way you get a fact check. Okay, if you really like a fact check,
Okay.
it is doable. It's doable, and usually, how long does it take? I would say normally maybe half a year. So starting from you start LeetCode, and then every day doing one problem, and then start to speed up the 2, 2, 3, 3, 4, 4, 5, 5, and then when you are really good, you can do 10 plus problem a day.
Oh wow.
Yeah. Okay. You can do that. In the beginning, very hard. Maybe on 1 week, one problem you cannot solve it.
That was me. That's me.
That's typical. Okay. That's
right.
typical.
I'm like, that's me.
That's typical. Not only you. I mean, a lot of people do struggle like that. Okay. But the speed will pick up. Okay. Take notes. Watch video, okay, redo it many, many times. These are the only thing you do, but you can see that actually your data structure course, algorithm course, are they important? Yes, they are important only by 5%.
Oh, wow.
Most of the time you are struggling, you struggle and you learn, okay? The thing that they can be taught by the lecture is very few, very little knowledge you will gain from there. Okay. Do you need that? Yes, you do need to have the basic data structure knowledge or algorithm knowledge. Yes, you do need that. Okay. Otherwise, you don't know what's dynamic programming. You don't know what is tree. You don't know what is queue. But detailed programming is way beyond that 5% knowledge. You know what I'm saying? But if you try to rely on some people teach you the whole complete lecture on interview skill, sorry, there's no such thing as this. Okay, they can only contribute 5%, 10% to your interview. Okay, it's impossible that you go to a course or even go to MIT to take the course for the interview skill set. Okay, very hard. Okay. Those kids at MIT are good because they are smart, right? It's not because they have a super data science, data structure book to help them, right? That's the difference, okay? But to work hard, okay, okay? Doable, doable, but it takes time. A lot of people give up just because they cannot handle the pressure. Okay. So if you do one problem a week, 2 problem second week, okay, and then 3 weeks later you decided, okay, let me take a break, and then 2 months later you come back, okay, sorry, you go back to the ground zero. Your learning curve will become like this. You like this, go up and then go down, and then go up and then go down. And here you never break anything. But if you do this, if you do speed up more and then you drop, speed up more, and drop, you will actually eventually win. You know what I'm saying?
Mhm.
If you are following this pattern, you are getting nowhere. Okay, you have to have an uptrend. Uptrend. Okay, you must follow some uptrend. Yeah, struggling is very important. Okay, struggling is very important in coding practice. And our course right here trying to teach you the whole view of what is language translation. Okay, what is language translation? So we designed the course in such an order to look at what are the different features of the language. Okay, from data point of view, from program binding of view, and from programming paradigm point of view, and then looking into the translation part in the second half. Okay. Okay. Any question?
No, thank you.
No. Can we conclude it today up to here, because I do not see any other student coming.
Sure. Thanks, Professor.
Oh,
Yeah,
thank
if you still have questions, you can stay. Okay. Otherwise, we'll be dismissed right here. Okay.
Thank you, Professor. You're so encouraging. I appreciate it.
Yeah.
You know, my code, and when I send my assignments, is not the greatest, but I did do it, so it'll get better.
You'll get better. Yeah. Anytime you're welcome. Okay. Even after class finish, if you do need a recommendation letter or something, I can still offer help.
Oh, thank you.
If it does help, okay. If it does help, but I don't know nowadays whether they still read it or not. I don't know. Okay. Okay, and we are dismissed here. Okay. Thank you. Thank you for.
Thank you. Take care.
Bye now.